Okay, we are here with another question, and that is question number 5. And question number 5 is a bit lengthy question. The solution might not be that much lengthy, but the statement is long, so we need to read it wisely. So the question says that one end of a light and extensible string is attached to a particle A. So this is your string, and it is attached to a particle A. Its mass is 3 kg. The other end of the string is attached to a particle B. The same string is attached here with a particle B of mass 4 kg. Particle A is in contact with the rough plane. Okay, so that needs to be written. This part is rough. Okay, then they say inclined at 30 degree, that is already mentioned on the diagram, to the horizontal, and the particle B is in contact with a smooth horizontal plane. This part is smooth. Okay, what is the difference between rough and smooth? Where the surface is rough, that means that you have a coefficient of friction and frictional force over there. Now, the second thing is the other end of this second string is attached to a particle C of mass 5 kg. Now, the same string is moving on another pulley, and it is attached with a particle C, which hangs vertically. Both strings are taut and pass over a small smooth pulley that are fixed at the ends of the horizontal plane. These are the two pulleys. The string is taut, so obviously that means must be the tension. The part of the string from A to the pulley is parallel to a line of greatest slope of the inclined plane, and A, B, and C are in the same vertical plane. The system is released from rest. Now, this is also an important thing. When it is released from rest, initially the velocities were 0. In the subsequent motion, C moves vertically downwards with acceleration 2 meters per second. Now, one more thing to represent should be that this is going to move vertically downward with acceleration 2 meters per second square. And neither A nor B reach a pulley. So yes, it will move vertically downward, but the A and B won't reach pulley. This just moves downwards like this. Find the tension in each of the strings. Okay, so let's represent first the tension, mention how it would be. Tension would be always be away from the point of observation. So one tension we take to be towards the pulley, away from the point of observation. Point of observation means the particles are our point of observation, and this will be one pair of tension because they are sliding on the pulley, so they will take them to be one, and there will be another pair of tension now because it is attached with some particles, so here is a break in the string. Now these two tensions will be similar, or instead you can take, yeah, that's fine. Okay, now we need to find the tension. So for this reason, to find tension, first we should be resolving the forces that are not horizontal or vertical. Starting from the first force, that is your weight. So it will turn out to be 5g. Then secondly, this one, that is on inclined plane. This will be 3G. This is your 30-degree. No, not this one. The internal angle will be your 30-degree. Yeah, this side will become 3G cos theta along the angle, and that theta is 30-degree. And this opposite to the angle becomes 3G sine 30. Yeah, that's it. Now, when we need to find the tension, so let's take the first thing. Wherever there is acceleration mentioned, we do apply forward minus backward equals MA. What is the forward force? 5G. What is the backward force? Just tension 2, and this is going to be equals to M times A and 5 times 2. So from here, we can clearly get the T2, and that we get found to be G, where G is 10. So T2 will be equals to 40 newtons. Okay. Now let's apply the same for your tension 1. And how can we apply that? As your whole system is moving to the right, so apply it on your particle B. Here we have applied on particle C. Now apply the same forward minus backward on particle B to get the second tension. So your forward is, in that case, is T2. Backward is T1 equals to 4 times acceleration, and that will be the same. So let's apply 40 minus, and the tension equals to 8, and T1 will be equals to then 32 newtons. Now talk about part B. Part B says find the coefficient of friction mu between A and the inclined plane. So that means we have to deal with this part of the this part only. Okay, so let's take that. For particle A, we are applying the same forward minus backward equals to ma because there is some acceleration. So for particle A, forward forces minus backward forces equals to ma. So what is forward for particle A? T1 is forward, and 3G sine 30 is also, 3G sine 30 is backwards also, because the body is moving forward, so there must be frictional force F equals to mu r. Okay, and to find out mu r, we need to find r. And what is r? R is going to be equals to 3G cos 30, because up equals to down. Like vertically, there is no net force, so up will be equals to down. So first let's get that. I'm taking this whole working on the next page. So let's copy this here. And we are applying for particle A, so forward minus backward. So forward is T1, backward is 3g sine 30, and mu r equals to MA, and M is 3 times A is 2. For R, let's write what is R. Your R is going to be equals to 3g cos 30. Cos 30 is root 3 over 2 times 3 times 10 will give you 15 root 3. Okay, so now substituting in the values here, T1 we found to be 32 newtons. So 32 minus 30, and sine 30 is 1 over 2. So minus 15 minus mu times 15 root 3 equals to 6. And now solve it. We will get mu to be equals to 11 over 15 root 3. And yeah, you can write it in the decimal form as well, 0.4233. So this is your mu. Now let's look into part C. When the system has been in motion for 1.5 seconds, the string attached to A breaks. Find the total distance that A travels up the plane from the instant that the system is released from rest to the instant that A comes to instantaneous rest. So now this string breaks and we have to find the distance it has covered. So yeah, let's take that to the next page and try and solve part C. Okay, so for this reason, we need to find a few things and we need to understand a few things. Like, firstly, when the particle we are focusing on particle A, this one. So when initially when the acceleration was 0 point, sorry, not 0 point, the acceleration was 2 meter per second square. What was the velocity with which it was moving up? Okay, because the same acceleration it had. So they say it was in motion for 1.5 seconds. So during these 1.5 seconds, what was the velocity? So as in that there was a constant acceleration. So we can use V is equals to, or we can use acceleration equals to velocity divided by time. So from here we can find the velocity to be a times t and 2 times 1.5. So what was the velocity with which it was moving when the string breaks? So that velocity is 3 meter per second. Okay, first thing we will be finding this. I think so we have less space, so instead of keeping it here, we should be moving it to the bottom because we have space here. So first thing we found to be with which velocity it is moving when the string breaks. Okay. Second thing that we need to find is the distance it has covered when initially when the body is accelerating with 2 meter per second square. Okay, the distance in 1.5 seconds, initial distance. Okay, so for that, as we have the constant acceleration, so we can use the equation of motion. What we have used here is not actually v is equals to a equals to v over t, rather v is equals to u plus at, the same thing. Why the same thing? Because the system was released from rest, so u will be 0 plus, that is why the answer is same. Otherwise it's better not to use a v over t because it's not constant. Yeah, this is a case of constant acceleration, so let's use the equation of motion rather than using just a simple v over t. So v will be equals to 0 plus 2 times 1.5. And that gives you 3 meter per second. Now the distance covered, we are going to use another equation of motion, s equals to ut plus half at square. So initial speed was 0 plus half 2 times 1.5 square. So from here we'll get the distance it has covered in the initial 1.5 seconds when the string doesn't break. Okay, and this we'll get it to be 2.25 meters. Now see when the string breaks. String breaks. Now your particle A is not gonna be moving with the same acceleration, rather the acceleration is going to be different. And we need to find the distance. So we can use the equation of motion that says v square equals to u square minus plus 2as or minus 2s depending on the acceleration, deceleration or the signs. Okay, so what is the thing? We know that it comes to rest, so final velocity is going to be 0. Initial velocity we found to be this one with which it was moving before the string breaks, so this is going to be 3. Distance we need to find, and acceleration we should be knowing with which acceleration it is moving. And to find out that acceleration, let's use again for the acceleration forward minus backward equals to ma when the string breaks after that. Okay, when the string breaks, now what is happening? Look, when the string breaks, now the body is moving in the reverse direction. Now it's not moving, no longer moving in this direction, it is moving in this direction. Okay, under the action of 3g sine 30, and your F equals to mu R will be upwards. It is always recommended to make another diagram instead of jumbling up all the things on the same. I have different colors, so I am just representing it on the same. Okay, so what will be forward force? That is dragging it downwards. Obviously, the gravity, the component of force that is making it move downward. So that is 3g sine 30. This is the only force. Yeah, the backward force will be minus mu times r, the frictional force, and equals to ma 3 times the acceleration. From this, we will be getting the acceleration. Okay, now substituting in the same mu and r values that we just found in the last part, and let's take that. Mu we found to be, sorry, mu we found it here. Mu is this, and r is this, 15 root 3. So let's substitute the values. 3g is 3 times 10 is 30, and 30 multiplied by sine 30 is 1 over 2. So it gives you 15. So I'm directly solving it and writing 15 minus mu. Mu is 11 over 15 root 3. R is 15 root 3. This is why I kept this all in the same form rather than writing in the decimal form. We can easily cancel out a few things. Okay, and this gives you 3a. Now this is your acceleration. Now what you will find it to be, 15 minus 11 would be 4 over 3. Acceleration is 4 over 3 meter per second square. Now, actually, it comes out to be acceleration, but rather as it is moving in the, like, obviously it is decelerating because it is coming to rest. So we can use acceleration to be negative, because we didn't taken into account the forward and backward motion sign. So we didn't get a minus here, but still, as we know that it must be decelerating. So let's substitute in the values above in the equation of motion. But before that, let's arrange this a bit. Yeah, so getting back here, 0 square equals 3 square plus 2 times minus 4 over 3 times s, and let's find out the s. 9 square. Okay, taking this on the other side. Minus 8 over 3. S becomes 8 over 3s equals to 9 square. Sorry, 3 square is 9. And then becomes 27 over 8 as distance. And that distance comes out to be, yeah, 27 over 8. And that is 3.375. Now, this is the distance before the string breaks, and this is the distance after the string breaks. So the total distance will be total distance it has covered before coming to rest would be 2.25 that it has covered before the string breaks plus 3.375 after the string breaks. So this add up to give you 5.625. Now, one thing that I find a little, I just need to arrange this. The rest is all fine. This is all about your question number 5. I think so. I should be solving this acceleration first. It makes more sense. First, we solve the acceleration. And then we found this by using the equation of motion. We found the distance, and this is your total distance that it has covered. So yeah, that's all about your question number 5. I hope you understand this all. If still there is something that you are not finding, that is not understandable to you, you can write us in the comment box. Thank you.